important session actually. How to use the data book, right? Where you don't need to remember any equations. So just a minute, Vinay sir is calling. Yeah. Sorry, students, for this obstruction. I'll share the screen. Right. See, feel free to ask any questions. Okay. At the end of the class, I'm here to clarify you. I don't skip anything. Whatever is necessary, I focus, I concentrate more on it. Right. Whatever is already you have learned, whatever is already not necessary too much, I touch you. I give the overview of that. That means that is extra thing. That is extra thing. Right. Okay. Is the screen clearly visible now? Can
Yes,
anybody?
sir.
Yeah. Thank you. So this is the thing we have discussed, viscosity, and whenever you come to the fluid mechanics, you already have studied about the um, what it called momentum equation, mass and momentum equations, right? Mass and momentum equations. And here additionally we have to study about the energy equations because energy is in the form of heat and work. Right? We are talking in the heat transfer. That's the reason we have to consider the energy here. That energy equation is additionally. Right. So these things we know. At the same time, these things, what is the mass conservation of mass equation is this. For example, if we consider the unsteady state with respect to time, then this becomes the equation which we have already learned in our fluid mechanics by considering a small elemental volume for the polar coordinates as well as for the cylindrical coordinates. Right. So after that, after reducing this, because if you take the rho as common, at the same time, if you consider the steady state, if it is a steady state, this becomes zero. This becomes zero, and this is the final equation. Rho, take the rho common, this rho becomes zero because it is equal to zero. So if I send this side, it is zero. So the final equation is dou u by dou x plus dou v by dou y plus dou w by dou z is equal to zero. Right. For example, if it is a two-dimensional flow, third dimension z direction becomes zero. If it is a one-dimensional flow, d dou u by dou x is equal to zero. Right. So these are the background story, which already prior knowledge. This is the past knowledge which we have learned at fluid mechanics in the course. Right. So this is also dimension analysis. Also we have studied, but we're supposed to skip it. But this is important topic. That's what I am focusing on, working on SPI theorem. So all these things you can go through it. And if you see, these are the very important for an engineering student or an engineering graduate, right? So which would be very important for the problem solving, right? These units are important, each and every units, right? So for the units, the fundamental dimensions also we know. The fundamental dimensions are 3 here. MLT we have studied so far. M indicates this is for the mass and all. L is nothing but the length and the volume, area. T indicates the time. Additionally, theta is here. That theta indicates temperature. Whenever there is a temperature, that means whenever there is incorporation of energy, then theta will also be incorporated, right? So if you take the temperature is theta. Like that, these are the fundamental dimensions. If you know these fundamental dimensions, for example, if you see here, you observe density, unit of density is kg per meter cube. Kg is nothing but the fundamental dimension is m. Meter cube, the fundamental dimension is L, right? So divided by L cube. Or I can write this as ml to the power of minus 3. Very simple. If you know the SI unit, that becomes easy to write these fundamental dimensions. Without writing this, no problem can be done in dimensional analysis. For example, the work or energy, it is in Newton meter, right? Newton is nothing but unit of force. Meter I have, right? So there is no fundamental dimension for Newton directly. Newton is nothing but Newton is equal to F into A. We know that, right? What is area? F into A. F is nothing but force. This is nothing but acceleration. Sorry, acceleration. Yeah, Newton is a force. Sorry.
kg meter per second square.
Yes, sir. Newton is equal to kg meter per second square. Good. But what is this? F? F is equal to again ma. F is equal to ma. Sorry. F is nothing but kg. This one is meter per second square. Right. Energy is equal to force into distance, displacement. That's the reason we need this force. Force is equal to ma. M is nothing but kg. This per meter per second square. Kg is m. Right. At the same time, meter per second square. L per t power minus 2 into, again we have 1 meter here, that is L. That is L. If you simplify, ml power 2 equal. Like that we have to simplify it, right? If you remember it is well, but remembering is very tough task. For each and every unit, impossible, right? So if you know this, you can derive this, right? For example, thermodynamics quantities. So far you studied here, right? Next, if you come to the thermodynamics point of view, so heat is joule. I asked you to asked you to write the fundamental dimension for joule. Right? What is joule? Joule is nothing but again Newton meter. Newton unit kg meter per second square. Kg meter per second square into again meter. Right? So kg meter square t power minus 2. T power minus 2. You have to get t power minus 2. This is wrong. Right? Like that, you must know the conversion. What is joule? Joule is equal to Newton meter. Unless you know the Newton meter, you cannot do it. Again, also Newton, it doesn't have the unit. You have to convert it. Newton is not unit of force. Force is equal to the m into area. Sorry, m into acceleration. M here. You know m is the mass. A is nothing but acceleration due to gravity. That is meter per second square. You can give the quantities. Suppose if I go for the thermal conductivity, these are the famous equations already we have studied. Watt per meter degrees centigrade. So the new term here, degree centigrade or Kelvin, it is introduced. So another fundamental dimension will come, that is theta. ఇక్కడ వరకు fluid mechanics లో చదువుకున్నాం. Right. So now we are going with thermal conductivity. In meter we know meter L, degree centigrade we know theta. But what is watt?
ఇక్కడ వాట్ దగ్గర t పవర్ -3 ఉండాలి కదా సార్.
ఎక్కడ
వాట్ పర్ మీటర్ డిగ్రీ సెల్సియస్ t పవర్ -3 కదా సార్.
This one. T power minus 3. This one. Am I right?
Yes, sir.
Okay. After deducing this, you will get this. That's what in many the resources there will be some mistakes. Okay, we should not blindly believe the textbook also sometimes. There will be some mistakes. Right. So what and then the joule per second. Right. Joule per second. These two you need to correct. Here it is minus, here it is also minus. Right, you cross check it. Joule per second. What is joule? Again, can we put this directly for joule? Yes or no?
Meter, sir.
Yes, joule is Newton meter. Right. From the top, reducing this, I can put directly either if you remember this. Right. So then after simplifying, you will get this. The additional term theta will be incorporated here. Simply don't what it called, because there will be, see, the numbers are correct 2 and 3, but there is a sign difference while typing. Maybe it is a typographical error, because in this much book there will be revisions and reviews. Each and every line cannot be reviewed. Right, some mistakes will be there. That's the reason we have to believe ourselves. Right, we have to follow the procedure and we have to get it. Right. So at the same time, specific heat, kilojoule per kg Kelvin. You don't bother about this kilo. Kilo indicates it's some constant, it's some value. Joule per kg Kelvin. Wherever there is degree centigrade or Kelvin, see, you will get theta. Here thermal diffusivity, there is no temperature, no degree centigrade. See, we did not get here theta. Right. So in that fashion, we have to be careful with the units and fundamental dimensions. Then we have to go for the Buckingham's phi theorem. Right, very simple. Buckingham's phi theorem is very simple. Just listen. ఇక్కడ పెద్ద ఇవి ఉన్నాయి, అవన్నీ ఏమి చూడు, మీకు జస్ట్ ఫర్ రిఫరెన్స్ ఇచ్చాను ఇదే. రైట్, జస్ట్ లిసన్ టు మీ, యూ కెన్ డూ ఇట్. రైట్. సో
సార్ కొద్దిగా గట్టిగా మాట్లాడతారా సార్, వినపడట్లేదు.
జస్ట్ a minute. Is it okay now?
No sir.
Is it fine?
Okay.
Yep. Yeah. Right. So now let us see the Buckingham's phi theorem. There is a Rayleigh's method also. Why we are not focusing Rayleigh's method? That is difficult to do that method, because if you go for the 2 variables, 2 to 3 variables, I can do with the help of Rayleigh's method. Right. So if these are more than 3 variables, Rayleigh's method cannot be applied. That is very difficult, very difficult. That's the reason Buckingham's phi theorem is important task. Right. So Buckingham's phi theorems, even from the 2 variables to many variables, it can be done easily. రైట్. సో బకింగ్హామ్స్ పై థీరంలో మీరు మెయిన్లీ గుర్తుపెట్టుకునేది fundamental dimensions MLT. If there is no energy, MLT. Energy and temperature కూడా ఉంది అనుకోండి theta. These called as the fundamental dimensions. First we have to identify if the given problem in the given problem లో మీకు energy related issues ఉన్నాయా లేదా అనేది first you have to focus it. Right. So if there is no temperature, let us say temperature is not there, Cp is also not there, thermal conductivity is not there, heat transfer coefficient is not there. Right, then you can simply fundamental dimensions of 3 MLT. Keep in mind MLT theta, that theta depends upon the temperature based property, right? So for example, there are n number of variables x1, x2, x3, x4 and 4 variables ఉన్నాయి, right? So x1 is need to be find out అంటే నాకు pressure find out చేయాలి, వీటిని బేస్ చేసుకుంటాం. And the x1 is a function of other variables. X1 is a function of other variables, right? So here what we do is we can write like this also. The new function f1 of all variables x1, x2, x3, x4 like that. Now here we have to introduce the phi theorem. What does it mean? What is the phi theorem? That is important, right? So first step in step 1, how many variables are given, you have to find out in the problem, including for example x1 is a function of x2, x3, x4, xn I said, right? So including this is the dependent variable, sorry, this is independent variable, this is dependent variable, right? So all variables, the right side variable, the left side, all variables we have to count. That variables is called as n. Those variables are called as n, right? What does it m? M is nothing but the fundamental dimensions, number of fundamental dimensions. How many number of fundamental dimensions are there? If there are in the given variables 3 fundamental variables are there or 4 fundamental variables are there, we have to identify, right? For example, if it is given a length, diameter, density and viscosity, right? And another factor, let us say the kinematic viscosity also. There are 3 fundamental variables only because there is no temperature one. Suppose if the thermal conductivity is given, then that becomes 4. That means whatever total variables are here, these total variables, including the right side and left side, right? Total variables is n minus m indicates number of fundamental dimensions. Are we 3 or 4? That's all. Either 3 or 4. Okay. So then that n minus m gives you the number of phi theorems. How many phi theorems you will get? For example, these variables are 5. These fundamental dimensions are 3. 5 minus 3 gives you 2 phi theorems. That is phi 1 and phi 2. That is phi 1 and phi 2. Right. So I can write that phi 1 and phi 2. F1 of phi 1 and phi 2 is equal to 0. F1, phi 1 and phi 2 is equal to 0. Right. So phi 1 is a function of something. Phi 2 is a function of something. While doing problem, you will clearly understand this. So to identifying the number of phi theorems are important. That is the step 1. Right. The number of phi theorems purely depends upon the what is called total variables minus the fundamental dimensions. Total variables minus the fundamental dimensions. This is very, 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 very important. Unless you identify number of phi theorems, problem cannot move forward. In addition to that, there is another thing that is called as the property selection. There are 3 types of properties. If it is a normal problem, if it is not the temperature problem, right? Geometric property, flow property, fluid property, right? Geometric property, flow property, and fluid property, and another one is the temperature based property, heat property or temperature based property. You cannot say heat, but temperature based property, right? So for example, geometric property and it depends upon the length, diameter, height, area, like that. All those things. Right? Flow property. What are the flow properties? Acceleration and velocities. Those are flow properties. In fluid mechanics, we have studied what is the acceleration in this direction, what is the velocity in this direction. We have studied a particular fluid. Right? Next, fluid property. How much mass, density it has, how much viscosity it has, how much surface tension it has. That is the fluid property. The properties are not same. It has to be calculated. It has to be classified. Right? So the properties can be classified into geometric property, flow property, fluid property. ఈ మూడు రావాలి. ఏది ఏ ప్రాపర్టీ అనేది రావాలి. ఫర్ ఎగ్జాంపుల్ ఐ ఆస్క్ ది వాల్యూమ్, డైరెక్ట్ వాల్యూమ్ ఏ ప్రాపర్టీ కింద వస్తుంది? జామెట్రిక్ ప్రాపర్టీ. రైట్? వెలాసిటీ, అదే వర్టిసిటీ, ఫ్లో ప్రాపర్టీ. రైట్? Suppose kinematic viscosity,
Flow property.
Fluid property, kinematic viscosity. Right? So in that way you have to define it. Right? Why? And the differentiation వస్తే కానీ మీకు repeating variables అని చెప్పలేము. At the same time, another thing is temperature property. Temperature property. In temperature properties, what will you get? Specific
Thermal conductivity,
heat transfer coefficient, right? Everything you will get, right? Which are based on the temperature. Those properties you will get. For example, నేను ఇప్పుడు temperature, energy consider చేయకుండా just only I'm considering only these remaining three properties: geometric property, flow property, and fluid property. Right? So repeating variables, selection of repeating variables are important in phi theorem. Okay, selection of repeating variables are important. In repeating variables, one property must be geometric property, one property must be flow property, one must be fluid property. Right? If there is no temperature, if temperature is also there, one must be temperature property in repeating variables. Right? Remaining variables will not repeat. For example, in the given properties of system, L, V, rho. Right? L is the geometric property, V is velocity, it is a flow property, rho is density, which is fluid property. Right? Suppose if thermal conductivity is given, thermal conductivity, this is the temperature based property. Right? So like that, repeating variables need to be given. So say for example, L and area, L height, rho cannot be given because L, H and rho, it cannot be given. L and H both are geometric properties. Right? This is fluid property. So it need to be replaced with the fluid property. Flow property. This is fluid property. Like that you have to keep in mind. First step is you have to find out the number of phi theorems. Second step is you need to select the repeating variables, which variables are repeated, and remaining variables will not repeat. Right? These two things are very important, and then we have to go for the phi theorem. Suppose number of phi theorems, phi 1 and phi 2. There are two phi theorems, right? So these to the power of some constant, these to the power of some constant. So, yeah, coming to the previous slide. Yeah, what do you need here? Do you want me
sir.
to?
Here, as you said, x1 is a function of independent variables.
Yes.
Yeah, but in the equation 1 again you have equated it to 0. Why it is equated to 0, sir? Why x1, the whole variable is?
These are the total variables. Okay. These are the total variables, out of which I need to find out some variable. For example, I need to calculate the acceleration. Right. So for example, I need to find out the force. Let us say force is one variable here. Force is depending on
Mass and acceleration.
Mass into acceleration. Right. So the force is a function of these two parameters, these two variables, right? So this is the equation. This is the thing we have to obtain. But how many variables are there totally? Totally, there are three variables. Irrespective of dependent and independent variables, we can write the equation like this and equate it to 0. Just for simplification, for showing it out. That's all. But our ultimate intention is to find out the P is equal to MA with using the dimensional quantities.
Sir, in order to find, we have been integrated also, but here in this condition, whenever to obtain 0, we'll be doing differentiation now.
No, not differentiation. While doing problem, you will understand. Don't worry. Just in 1 or 2 minutes, I will go to the problem so that you will understand. This is for the sake of writing it. The presenting of variables. Presenting of variables, whatever variables are given for particular analysis, those variables, it is the dependent variable is a function of something, some variables, right? If you want to write the total variables, the equation is a function of equal to 0, according to this what is called Buckingham's pi theorem, right? While doing a problem, you will understand. Don't worry.
Sir, as you said, these are all independent variables. Then why do we consider repeating terms?
As per the procedure of Buckingham's pi theorem, you need to identify the pi theorem as per the number of variables and fundamental dimensions. That is one step. Second step is you need to repeat it, right? You need to repeat it. It must contain geometric property, flow property, and fluid property. I said that is a procedure. That is a procedure.
So can you say any one application about it? As you are saying it repeating now, how can we do it?
That's what
Is it an assumed step or it's a practical approach?
Of course, man. Just next there is a problem. I said when I go to a problem, you can understand. Just a procedure I'm explaining now.
Okay. Parallel you can do now.
Parallel, how can it possible with the theory and problem?
Okay. Sir.
Without explaining this, if I go to problem, do you understand? Tell me. Directly I apply there what are the repeating variables, geometric property, flow property, fluid property. Directly I apply there. Do you understand that? No, again you will ask for what is repeating variable, why this, like this you will ask. This is the standard procedures by Buckingham's. He has invented this procedure to solve the problems.
Okay, sir.
Right. So these are the repeating variables. The rule for the repeating variables, it must be geometric property, it must be flow property, it must be fluid property. Right. So you have undergone this in your fluid mechanics, right? You must have these basics. Right. So let us see a numerical. Right. See the resistance R experienced by a particularly submerged body depends upon the velocity, length of the body, viscosity, density, acceleration due to gravity. Right? It is asking you to calculate the expression for R. Totally, how many variables are here? Total variables. Resistance is variable.
Phi, sir.
Phi.
Velocity is variable. L, mu, rho, and G. 5 variables. 6 variables. Total variables I asked. R is also a variable. Right? R, V, L, mu, rho, G. Totally 6 variables. That is my N. Sorry. N. Where is the notation? Whatever. Right? So I can write this is as per the Buckingham's rule. It can be written like this. That means it make another function R, V, L, mu, rho, G equal to 0. Right? The total variables are I have written here. N is equal to 6. How many fundamental dimensions are there? Can anybody tell?
So once more repeat question.
how many fundamental dimensions are here?
MLT.
Yeah, ML
T.
T. You will find only 3 here. As I said in the first slide itself, these are the fundamental dimensions we need to identify. Right? This n minus m gives you the number of phi theorems. Right? N is the number of variables, total number of variables, including the variable which we are going to find. Right? M is nothing but the number of variables. So among these variables, MLT is there or MLT theta is there. That is the important. Right? So here V, velocity, length, viscosity, density, and G. We did not get any we did not get any temperature quantity here, temperature based quantity. Even also resistance, it is nothing but a force. Right? Here also we did not get any temperature. So the number of fundamental dimensions are 3. N is equal to 3. Right? So how will you calculate the number of phi theorems? N minus m. N minus m is equal to how many? 3. So what are those phi theorems? Phi 1, phi 2, and phi 3. Right? So these phi 3 terms we need to calculate. Right? So here, that means I need to find out the resistance. I need to find out the resistance here. Okay. So R is equal to, R is nothing but resistance. I need to find out the fundamental, as I said, from the units you have to derive the fundamental units for each and every variable. Each and every variable. Right? So we can write for velocity, we can write for viscosity, we can write for rho, and for G, again for length also we can write. Right? So he has given C here MLT. In this problem, M is equal to 3. Total variable 6 minus 3, we introduce 3 phi theorems here. Right? So 3 phi theorems, phi 1 is a function of phi 2 and phi 3. It can be like this. Or phi 2 is a function of phi 1 and phi 3. Or phi 3 is a function of phi 2 and phi 3. What does it mean? What phi 1 indicates, what phi 2 indicates, what phi 3 indicates. You can write in either of these 3 equations. Because phi 1 is equal
Sir,
to
for
function of
phi 3, phi 1 and phi 2, no, sir.
for phi 3, phi 1 and phi 2. Okay. Right. So, for example, if I take phi 1 is equal to function of phi 2 and phi 3. That means it contains the dependent variable. These are the independent variables. For example, the dependent variable in phi 2 term, then these two becomes independent variables. In phi 3, if it is dependent variable, then it is phi 1 and phi 2. So like that, we have to do it. So before going to next slide, I am explaining this. It is clearly given in the next slide. Right. So the number of phi theorems are introduced. We found that number of phi theorems are 3. Number of phi theorems, phi 1, phi 2, and phi 3. Right? The function of phi 1, phi 2, and phi 3 is equal to 0. Right? We can write including all 3 phi theorems. Now, what is phi 1, what is phi 2, what is phi 3? We have to decide it. For example, phi 1, phi 2, phi 3. This is the next step. Listen here carefully. L, V, rho has chosen as the repeating variables here. L, V, and rho are chosen as repeating variables. Repeating variables mean for all 5 theorems, the same will be repeated. The same will be repeated. Suppose if I take in the LV row as repeating variables, remaining values are R, mu, and G. Right? So phi 1 in phi 1, L power A1, V power B1, rho power C1 into R I put here. Simply R. This may not be this order. It cannot be this order. Don't worry. You can put this R here. This mu can be placed there. Then, in that case, the phi 2 is a function of phi 1 and phi 3. Right. So here, the phi 1, this is a1, b1 and c1. These are the constants. These are the constants. Right? Here there is no constant. Again, repeating variable, second constant. Because this is phi 2, we are introducing second constant a2, b2 and c2. And this is mu, another variable. Phi 3, a3, b3 and c3. This is another variable. So totally 1, 2, 3, 4, 5, 6
Sir,
variables
why
are over.
why we have to select mu and g, sir?
Mu and
G, why we are taking only mu and g, sir? We can take another variables also, no, sir.
which variable are given? Tell me. Other than these variables, what are the variables present here? It's asking you to calculate the resistance with respect to the given variables. You need to acquire the equation is asking. Unless the variable is not given in the problem, will you take it from outside, which is
No,
not
sir.
given?
No,
Then
sir.
whatever values we are given, whatever the variables are given, those values we are putting here. Because we chosen these values are repeating variables, the remaining variables are these. That is the reason we are not repeating this. Only, for example, if it is a flow property, only one property has to be considered as the repeating variable. If it is a fluid property, one property has to be repeated as the considered as the repeating variable. Right? If it is geometric property, one need to be at a time, one need to be repeated. That is the rule for doing this Buckingham's pi theorem. The remaining need to be given. For example, in phi 1, I put r. What are the remaining variables? Mu and g are there. Mu and g are there. Suppose I am putting mu. What is the remaining? G. The g I have put here. You don't bother about this order. You can put this g here. You can put this r. You can put this mu here. Right. So the variables from outside disk we cannot get it. Whatever given in the problem, just use it. There is no assumption here. Assumption to bring some other properties or some other variables from outside. Clear? Right. So here, the phi 1, phi 2 and phi 3. What we have to find out? We need to find out the resistance. Our target is you need to find out resistance. So the phi 1 is equal to is a function of phi 2 and phi 3. We can write like this: phi 1 and phi 2 and phi 3. Right. So that means the whatever finding parameter is at phi 1, that is the reason phi 1 is equal to function of remaining phi 2 and phi 3. Suppose if this r value is somewhere here, Could anybody confirm? Is my voice clear?
Yes, sir.
Yes, sir.
So there was some
But
power
low, sir.
failure. I didn't have the backup actually. So I changed the.
Sir,
Yeah.
sir, whether we are using
Audible?
this Buckingham pi theorem for finding thermal coefficient, sir, heat transfer coefficient?
See, whatever I am going to discuss in future, you have the already the prior doubts you are having. My intention is to discuss all those things. Understood? I will discuss those also. Whatever I am going to discuss, because these are the basic knowledge to learn it. Whether you have learned properly this or not in your fluid mechanics, that's the reason I am stressing here. After completing this, immediately I will go to that only. But when I am teaching you, people are interrupting me. The things which I am going in the next slide, if I want to talk something, you people are asking in this slide only when I am explaining. Right? Don't worry, that also I am going to explain. Just a minute, I'll get back to you. Okay. So don't worry, don't hurry also. Okay. I will explain, I'll make you clarify, don't worry. That is the reason I'm spending time, because you people will get confused to do this. I know. Right. So based on this, these are the 5 theorems. I guess you understand this, how to put the 5. For example, this R is here and the mu is somewhere here. Then it becomes phi 2 is a function of phi 1 and phi 3. Right. So this is the way we have to define, because the calculating parameter is R here. What equation we will get? Let us see. R is function of something, some equation we have to derive with the available variables. The available independent variables, we need to find out the resistance R. These are the phi 1 and phi 2 and phi 3. Now we have to do the simple calculations. Very simple calculations. Right? So let us say first phi 1 term let us take. First let us take the phi 1 term to avoid this constants. Right. So here I can write this phi 1 as m power 0, L power 0, T power 0. That means that is MLT in the form of MLT. Right? It has the powers as 0, 0, 0. This is the phi 1 as per rule of the Buckingham's phi theorem. This is another procedure. Right. So even for phi 2 also m0, m power 0, L power 0, T power 0 we have to take. For phi 3 also m power 0, L power 0, T power 0 we have to take. Right. So now if you see what is the fundamental dimension of L is nothing but length, so we write here L. Velocity meter per second square. So the fundamental dimensions we have written like this. We have to put in bracket because for total velocity power of v1. That is the reason they put bracket here. Many people avoid the bracket. Right. So next step. This is not phi, this is rho. Right. It has given wrong here. Rho. Rho is nothing but what? Kg per meter cube. What is the fundamental dimension for kg per meter cube? Kg is m, meter cube is L cube. So if it goes in the numerator, then it becomes L power minus 3. This is very simple calculation. Normal calculation. Right. Next, R is nothing but resistance. Here it's a force. Force is nothing but m into area. So MLT power minus 2. Just what we have written, fundamental dimensions of given equations are written. So this will be repeated for all cases, all 3 cases. Whatever I highlighted, those will be repeated in all cases, but the constants will change. A1, B1, C1. there A2, B2, A2, B2, C2, A3, B3, C2. So only thing this will be changing, because in case of R, this is this, right? Now we have to equate both sides. We have to do some analysis here. M parameters తీసుకుందాం. Equate M. Whatever M is here, M power C1. And because the base M power 0 is also equal to here M power C1. For example, I'm telling here, in the next slide you will see again M power C1 again into M, again into M, right? So because this is the base, this is power, this is base, and this is also power, right? So bases are equal. If the, for example, very 7th class mathematics, Malay, M power 0 is equal to, bases are equal, so the powers need to be added, C1 plus 1, right? In both sides, if bases are equal, powers are also equal. C1 plus 1 is equal to 0, so I can find out C1 here. C1 is minus 1. That's the way you have to calculate one constant. Suppose if you do the calculation for M, you will get like this. Again, you have to do for the L, you have to do for the T. In this equation, if you observe, this is the thing I have done for L again. L is equal to, anyway, 0, allow 0 left side, A1 plus B1 minus 3C1 plus 1. I go back to that slide again. But if I come here, if I come here, L is L 0 is equal to, or equal to 0 is equal to L సంబంధించింది ఏముంది ఇక్కడ, L to the power of B1, L to the power of 0 is equal to L to the power of B1, L to the power of minus 3C1, right, into L. So what it becomes, 0 is equal to B1 minus 3C1 plus L. B1, the A1 also is there. So in the A also there is L. Sorry, I forgot this. Here also there is one L. Here. So L power A1. L power A1. Right? Again, these bases are same. L1 A1 plus B1 minus 3C1 plus 1. So that is also equal to 0. The same way you have to do for the T. You have to do for the T. You will get like this. So you will get C1, you will get B1, you will get, if you get B1 and C1, you substitute this C1 here, you substitute this B1 here, so that you will get the A1. Right? Then again go to the phi 1 term. In this term, substitute this A1, B1, C1 values. Phi 1 is equal to A1 is minus 2, B1 is minus 2, C1 is minus 1 into R. So this R is equal to R by L square V square by rho. Right? So this is the phi 1. This is phi 1. Now we got the phi 1 value. Similarly, in the same procedure, you have to find out the phi 2. Right? The constants you will get in C2s, A2, B2, C2s like that. So Allah again, you have to get the phi 2 value. In the same way, you have to go for the phi 3. You have to go for the phi 3. Again, you have to find out the phi 3 value at the final. So I'll bring into a common function here, right? So common function I have written phi 1 of a function of phi 1, phi 2, and phi 3 is equal to 0. But I know that phi 1 is a function of phi 2 and phi 3, because this thing is, I need to find out this one, R value, right? So the R by L square V square rho is equal to phi of mu L V rho. This is the thing. This is phi 2 and this one is phi 3. So I need to find out R, let us say. Keep that R this side. and L square V square rho square into it is a function of the remaining parameters. That is the derivation of this particular resistance with respect to other variables. With respect to other variables. So the major task is to finding out phi 1, phi 2, phi 3. If you put in place of plus, minus, entirely it goes wrong. Right? In that simplification, you must be aware. You must be aware. Right? This is the dimensional analysis problem for non-temperature based thing which you already have studied in your fluid mechanics. Next, so this is the simplification of that. You do this problem, and we're already chasing the idea. Impose are chained for practice. Unless you practice, you cannot get you can't even do this problem. Based on the procedure, same procedure, you try to do. Yeah.
Previous slide, last step, sir.
Yeah.
This one, sir.
What happened? What happened? This is function of something, right? I said phi 1 is the function of phi 2 and phi 3. So this is the phi 2 value and this one is the phi 1 value. Okay. So here there is a possibility. This is the function. So we can write in reverse direction. It doesn't matter. This is simplification only.
Yes, sir.
Simplification only. You can stop here. You can stop here. It doesn't matter. Further steps. There is another step also in the next slide. Right?
Yes, sir.
So the ultimate thing is you need to get this R is the dependent variable. It should be a function of other independent variables. The same, these are independent variables. These are also independent variables. This is also, anyway, this is going this side. Right? Whether we are getting or not, that thing is important. For example, in the question, he has given that show that some equation is equal to like this only. For example, R is equal to L square V square into rho. You show like this only. Then you have to cross check it. Because, for example, he has given some variables and he is asking you to calculate some equation with respect to some other variables. Understood?
Yes, sir.
Yeah. See here, if you take this side, what happens? This side, this is multiplying and simplifying only, right? And this is the final one. So you try to do this problem. Delta P, pressure difference, diameter is given, length is given, velocity is given, viscosity, rho, roughness, right? And he is asking you to calculate the delta P equation, the famous one. This is the famous equation. Then I the fluid mechanics change. Right. Next step, I'm not going to do this. Just I'm explaining how to do. This is a forced convection problem. Heat transfer coefficient is given. Density, diameter, V, mu, Cp, K, everything is given. What dimensions are asking for? In the problem, you don't give this. Just he gives these variables. He will ask you to calculate the Nusselt number equation. Nusselt number is nothing but it is a function of Nusselt number is equal to HL by K under 1. HL by K or HLC by K. This is also equal to, it's a function of, I said, Reynolds number and Prandtl number. Reynolds number and Prandtl number. Okay, the forced convection. Natural convection is the Grashof number and Prandtl number and in a class one. Right. So anyway, you need to get this equation. Nusselt number is equal to HLC by K. HLC by K is also equal to Reynolds number. What is Reynolds number? Rho Vd by mu. What is Prandtl number? Mu Cp by K. I'll discuss those numbers also. Prandtl number is new thing. Reynolds number is old one only. Anyway, the Nusselt number also I spoke yesterday. Right. So this is the things we have to derive. If you go to any reference textbook, you will get it. Right. Don't worry. Next here. What are the fundamental dimensions here in this problem? Can anybody tell me? Total variables, how many total variables are here?
7.
7 problems. The 7 variables. So n is 7, How many fundamental variables are here? Because H is given, Cp is also given, thermal conductivity also given. These three properties are a function of temperature. So the fundamental dimensions we have to take it as 4. If there is no temperature based the properties, then only 3 only you have to take. Right. So 7 minus 3, 3, 5 theorems. 5 1, 5 2, 5 3. It is clear. Next, what are the repeating variables? That is important here. The first thing is the repeating variable is here he has taken D. L is not given here. Diameter is only the geometric property. Right. Next, this is the flow property. Density is the fluid property. H is the temperature property. ఇదే ఆర్డర్ తీసుకోవాలని లేదు. You can put this H here, you can put this H here. At the same time, one more thing I can say here, the density is the fluid property. Mu is also fluid property. In place of density, you can take mu. You bring this side. They procedure lo cheyaలని లేదు. Any fluid property you can take, any flow property you can take, any temperature property. In place of this H, you can take Cp also, you can take K also. Anything can be taken. Ultimately, that is the beauty of this method. Ultimately, you get the same answer. Right, finally. Right. So these are the things. You see whatever remaining variables you have to put there. The same procedure you have to do. First thing is we need to find out A1, A2, A1, B1, C1, D1. D1 is introduced. When the variables are constants are keep on increasing, the complication, there will be complication in doing. Right. So again here m power 0, L power 0, ml t power 0, and theta power 0 I write here because theta is new term. The same procedure whatever we have done in the previous same solution. This is the solution you have to get. Nusselt number. It means HD by K is equal to 3 5 theorems. You will get 3 5 theorems. H is function of remaining 2, he said. Right. Problem. H is a function of remaining 3 2. If you do 5 theorem, you will get some H. HD by K. HL by K and HD by K also as Nusselt number. That we will be knowing in the coming classes. Right. So in that way, if you do, that means I did not put this procedure for this. You supposed to do and you acquire this. Right? Acquire it, you get this Reynolds number, rho dV by mu or rho LV by mu.
Spoonu. Numaka pachadi.
Right. So these are the things we have to derive it. This is for the forced convection. The same problem. I shared this PPT today itself. I shared the complete 2 units in the last yesterday. I share this. Do practice. This is also homework problem, right? Homework problem. Here we see. I'll tell you this beta G delta T. This total. What is this total? I'll tell you. Right. So again, this is the natural convection issue. Heat transfer coefficient of natural convection. Right. Again, you need to find out the Nusselt number. The Nusselt number is a function of some constant into Prandtl power and Grashof power n. I said see, it's a function of a Grashof number and Prandtl number. In the last class, I told you. For natural convection, the Nusselt number is equal to, it is a function of Grashof number and the Prandtl number. Right. So in this way, you have to obtain. Again, you have to see whatever the variables 1, 2, 3, 4, 5, and this all together is one variable. This all together is one variable. Right. So G is acceleration due to gravity. This beta is a constant value, the coefficient of volume. That means beta is nothing but again this significance of beta will study in there. So 273 plus TF. TF and the mean temperature, right? So this is 273 Kelvin per Kelvin or per degree centigrade. 1 by B. 1 by B is per degree centigrade or per Kelvin. Right. So next G beta delta T. This total you have to consider here. This G beta delta T is nothing. Delta T is nothing but change in temperature. Beta is per Kelvin. Delta T is again let us say Kelvin. And G is nothing but meter per second square. these two gets cancelled. Fundamental dimensions meter per second square you'll get. For this meter per second square, L P power minus 2 you'll get. That is the thing. Everything is same. H you know the unit, Cp you know joule per kg Kelvin. Only thing is this one, right? You do this, you start doing this. These are very important things because simply seeing and I perform in the exam means it is impossible unless you have the practice. It is like a cricket game, right? Now, normal cricket game is different. International level cricket game is different. Unless you practice, they won't take you to take you in the team. Right. In every way to get the good output, you have to clear practice. Right. So this is about the Buckingham's phi theorem. Next, one more thing is treat the about gap around 5 to 6 minutes, that is break, right? So due to the power failure and all. Let us see. Quickly, I'll show this, what is this, and then I'll go for the data book usage of the unit 1, how to use it, right? Next, for example, if it is circular geometry, we can take the diameter.
How much your son scored and how much my son scored and compare. Don't do that. It is not good.
People mute. 306. Right, I can take the diameter. For example, in central air conditioning system, there is a duct. In duct, what I have to do? I cannot take the diameter. It could be a rectangular duct or it could be a triangular duct. Right? For the analysis, for doing the analysis, if it is diameter, for example, HD by K, Nusselt number. This is diameter. If it is circular object, I can take directly diameter. But if the object is like this, I cannot take the diameter. For that, I have to take the equivalent diameter, DE. That equivalent diameter can be calculated 4 into area of cross section by perimeter. There is a standard Nusselt number equation in the data book. I will discuss that in the coming classes. And the knowledge you could evolve. Right. So, 4 into area of cross section by perimeter. For example, L into B, cross sectional area, LB, 4 into LB, 2 into L plus B, you will get this is the equivalent diameter. Whatever diameter you will get, you will substitute it. Suppose if the this is a hollow duct, hollow rectangular duct. If it is like this, what you need to calculate? How you need to calculate? Right? At the same time, outside it is rectangular, inside it is a circle. How to calculate the equivalent diameter? For example, this is a hollow cylinder. How to calculate the equivalent diameter? Those are also given in the coming slides. Very easy, simple, easy. As per the D is equal to 4AC by P. These are the things. D is equal to 4 into area of cross section by perimeter for the second case. If that is a hollow rectangular duct, right? If it is a cylinder, triangular also. I did not give the triangular. You do it for triangular. Cross sectional area of the triangular duct divided by perimeter of the triangle. This is A, let us say this is also A, and this is also A. Then what is the cross sectional area of this? Next, what is the perimeter? Perimeter is 3A, cross section is half into area into area. Depends upon the triangle. If it is a right angle triangle, the area will change. We know the basics very well. Right? Right. So for the annulus, this is the thing, because pi by 4 d square is for the circle and LB is for the. This is the geometry as given in the previous slide. For this is the thing. For example, if it is a hollow thing, which is having different diameters, then the equivalent diameter we need to calculate. So in this way, we have to calculate the equivalent diameters. So when the rectangular duct in the problem is given and the fluid is flowing, ask you to calculate the convective heat transfer, you should not skip it. Right? You're supposed to go through it. These are the non-dimensional numbers we use. Reynolds number, which is a familiar, right? It is the ratio of this inertial force by viscous force. Right? Each and every Reynolds number significance is here. If you want extra knowledge, you go through this, because these all not you don't get any theory and all. Right? If you get also, you can write it. The Prandtl number, it is the ratio of kinematic viscosity to the thermal diffusivity. Thermal diffusivity alpha we have studied. Kinematic viscosity mu. Right? After doing, you will get like this. It is Prandtl number. You remember this equation, either this equation. You don't need to remember any of this equation. Everything is given in data book. I'll make you aware of it by itself. This is the Prandtl number, because their Proud number, Weber number, all those things you have studied in fluid mechanics. That's the reason I could not incorporate here, right? So those are not required here. That's the reason I didn't do. Reynolds number is important. Prandtl number is important, because the Reynolds number and Prandtl number both are the function of Nusselt. For Nusselt number, these two are functions, independent variables, right? Next, Nusselt number, I said HD by K, HL by K, HL by K. If it is diameter, it can be HD by K, right? In place of this. These are the non-dimensional numbers which we use in the convection heat transfer. Stanton number. Stanton number is nothing but it is the ratio of this. If you know this, you don't forget about this. After solving this only you get. You must, if you know the Nusselt number, HLC by K, Reynolds number, this. After solving, you will get Stanton number, H by rho is equal. Right. Next, Peclet number, product of Reynolds number and Prandtl number. You get this one. You know the Reynolds number, you know the Prandtl number. That is Peclet number. Sometimes in the problem, he will give directly a Peclet number without giving the geometry. Then you can calculate. Peclet number is given, Prandtl number is given. If it is laminar flow, find out the Reynolds number. You find the Reynolds number. You can find, this is known value. This is also known value. This is not known actually. It is not given. We have to take it from properties from data book. Prandtl number values will not at all will be given. You have to take it from data book. How to take also I'll tell you. Right? These are the non-dimensional. Some of them. One more is Grashof number. Kretz number you don't use anywhere. This one is not used here. Post-graduation level they will use, but I kept it for some information. At least you have some numbers. What are the non-dimensional numbers you have? At least to learn that. And this is next one is important. The Grashof number. The Grashof number is inertia force, buoyancy, and viscous force. Right? Why inertia, buoyancy, and all? Because the natural convection takes place due to the buoyancy effect. Right? So after solving this, rho square beta g, there is a big derivation. The derivation is not needed. Okay, the derivation is not needed. Don't worry. Anyway, let us discuss the significance of it in the natural convection unit. Because the Grashof number and Prandtl number, again, Nusselt number is a function of Grashof number and Prandtl number. G beta, in the previous dimensional analysis problem, I said this beta is 1 by 273 plus TF. TF is mean temperature. What is that mean temperature? For example, it is the surface over the fluid is flowing. The fluid temperature is 20 degrees centigrade. The surface temperature is 100 degrees centigrade. The average of these two temperatures is called as mean temperature. This mean temperature plays crucial role to take the properties in both the convection, not only the natural convection, but in both the convection. So these are some of the non-dimensional numbers which we can see. So this topic I will discuss later. Any questions so far? Students? Yes? Respond, yes or no, so that I can move to the usage of data book. Are you there, students?
Yes, sir.
Yeah.
Sir, this Buckingham pi theorem is for heat transfer coefficient, sir.
Buckingham pi theorem not only for heat transfer coefficients. So whatever equation you want to derive with the given variables, you can derive it. For example, like Reynolds number on the Reynolds number formula cheppu. Reynolds number formula cheppu. Reynolds force is equal to ma and చూపించాలి. F is equal to ma. right? So f is dependent variable, m into area are independent variables, right? Then derive cheyadaniki we can do it. Not only heat transfer coefficient, heat transfer coefficient ke kaadu, right? You can do any type of analysis, but that must contain a fluid property, a flow property, a geometric property. In addition to that, if it is related to the temperature based properties, then this temperature based property also you need to consider. Okay? Understand?
Yes, sir. Yes, sir. Yes, sir. Thank you.
So now this is very important, my dear students. See, you don't need to put slips in exam because this is only slip book. మీరు స్లిప్లో ఈక్వేషన్ చేతిలో రాసుకొని వెళ్దాం అంటే మూర్ఖత్వం ఏమి ఉండదు. ఈ డేటా బుక్ పర్పస్ అదే. డేటా బుక్ యూ కెనాట్ డూ. ఓకే, రైట్. Heat and mass transfer data book, there are different editions, you leave it. You better follow this program. షేర్ అవుతుందా? నేను పెట్టింది షేర్ అవుతుందా? కనిపిస్తుందా? బాబు కనిపిస్తుందా ఇది డేటా బుక్?
Yes, sir.
Yes, sir.
Yeah. Listen here. Right. So, first of all, మనం డేటా బుక్ ఉంది కదా అని ఎక్కడ పడితే అక్కడ వెళ్ళకూడదు. Right. First we have to go for the contents. Right. The contents లో first there are property values. చాలా important. Metal properties, alloy properties, non-metallics అన్నీ ఇస్తాయి. ఈ gases, liquids. ఇది చాలా ఇంపార్టెంట్. కన్వెక్షన్ లో ఈ ప్రాపర్టీస్ ఇంపార్టెంట్. ప్రాపర్టీస్ తీసుకోకపోతే అసలు పనే అవుతుంది. Right? Anyway, these properties, if it is not given also we can take in conduction, but conduction will directly మనకి ఇచ్చేస్తాం ప్రాపర్టీస్ రాదలేదు. రైట్, మీరు చూడొచ్చు కొన్ని ఇన్సులేటింగ్ మెటీరియల్స్. ఫర్ సమ్ ఇన్సులేటింగ్ మెటీరియల్స్ యూ కెన్ గో త్రూ దిస్ particular page number. If you go, you will find it. Right? First properties. A particular a property కావాలంటే particular page number కి వెళ్ళాలి. అంతేగాని 1 to 90, 1 to 200 pages అలా తిప్పుతూ ఉంటామంటే అవుట్. It is not possible. Right? At the particular page you have to go and the required properties need to be taken. Right? Conduction. If you go to conduction heat transfer, see, this is steady state conduction. Steady state with heat generation. Last is it d square dou square t by dou x square plus qg by k equal to 0. What case by equations ఉంటాయి? Finn's equations ఉంటాయి. Lumped analysis, semi-infinite solid, infinite solids. You don't bother about this. This is not applicable to undergraduation. Right? So these are the conduction cases. Now let us see what are the properties and ఒకదాన్ని బట్టి ఒకటి ఎలా వెళ్దాం. For example, if I move towards the down, these are the properties. See, the first phase, properties values of metals at 20 degrees centigrade. Aluminum, like that. There are bronze, many metals. See, property values of metals at 20 degrees centigrade. The next phase it is continued like that. So these are the metals properties. Property values of metals at 20 degrees are as indicated. Remaining, what there only materials contain properties. Right? So don't bother about the solid properties. The variation of thermal conductivities of the metal. For example, if it is -100, how it is varying? At 0, 100, 200, 300. The temperatures that thermal conductivity allow variable. These are given here. Next, see thermal conductivity of metals. I have shown in the beginning of the class in the slide itself how it is varying graphically. Next, variation of thermal conductivity of solids, alloys. Next, these are one. Property values of some non-metallic solids. సార్ అలా స్క్రోల్ చేసేస్తున్నారు అనుకుంటారు. అవసరం లేదంటే జస్ట్ యూ హావ్ టు నో ఇట్. రైట్? ఇప్పుడు ఈ మెటీరియల్ తాలూకు టెంపరేచర్ 27 degrees, 40-60 thermal conductivity, rho value, density ఎంత ఉంది? Density is this much, right? And specific heat, all will be in SI units. the SI units of A value, CP, C and the CP specific. Okay. Next, if you move down, these are the properties of solids, and there are liquids also. Property values of industrial insulating materials, aluminum, silica, fiber, like that. There are many materials. Also, water properties, liquids here. Steam tables from Daniel. Whatever steam tables you used, those steam tables will also be available here. Like organic compounds. See, the molten salt, property values of molten salt, N-butyl alcohol. There are many properties. See, property values of liquids in saturated state. Saturated state like around glycol, engine oil. Engine oil problem we will do in where in the convection, right? Engine oil problem will be done. Property values of liquid in saturated state, right? Dry air properties will also be there. The water. So the water, what is the density of water at 0 degrees centigrade? Like that, right? So 20 degrees centigrade, 160 degrees centigrade, what is density? What is the viscosity, kinematic viscosity? What is the thermal diffusivity? What is Prandtl number? So what is specific heat? What is thermal conductivity? Everything is thermal conductivity fluid here. It's not solid. Water means it is a fluid. See, these are the values of thermal conductivity. Right? If you have book with you, you can take this. Next, if I go steam and dry air, vapor, right? All those properties, all the solid, liquid, and the gaseous phase properties will get here. You keep on receive dry air. Convection law, most of the problems will be done with the help of air only. Air is flowing over a surface, or air is flowing inside the surface, like that, right? So these properties are essential. While doing problems, you need to note down all these properties, including units, especially in convection problem. These are the in convection problems only will take this. 10 degrees centigrade another mean temperature. Mean temperature properties this one. I'll explain step by step problems only. The properties 10 degrees there this one. 15 another average here. 10 దగ్గర తీసుకోవాలి, 20 దగ్గర తీసుకోవాలి. ఈ రెండింటి యావరేజ్, అలాగే ఈ రెండింటి యావరేజ్, ఈ రెండింటి యావరేజ్, ఈ రెండింటి యావరేజ్. ఒకవేళ 16 అన్నాడు అనుకోండి, ఇంటర్పోలేషన్ చేయాలి. యూ సపోజ్ టు డూ ది ఇంటర్పోలేషన్, రైట్? Average I cannot take. Average అంటే 15 అంటే 10 plus 20 by 2 is 15, right? But 10 by 20, 20 by 2 is not an average, it is an interpolation. I tell you how to do the interpolation at the discussion of problems. So oxygen, carbon dioxide, sulfur dioxide, any gases. See, flue gases is flowing over there, flowing inside the tube, let us say. Appudu elaga. Next, hydrogen, ammonia, vapor ammonia, right? Carbon, many acetone, all properties. Steam is flowing, let us say, at 400 degrees centigrade. It is a superheated steam. At 100 degrees centigrade, it is saturated steam, right? So what are the properties? Mainly fluid, under fluid property, geometric property, flow property, both are important. That's the reason we study the fluid mechanics and as well as heat transfer. Now, here you have to concentrate. Babu, మనం starting లో ఏం డిస్కస్ చేసాము? Can anybody tell me? Starting లో చెప్తారా ఎవరైనా? Yes, speak out, somebody. There are some active participants. Yes. Okay. Anyway, right. So modes of heat transfer we have discussed, right? Conduction. The resistance I said L by K is the temperature profile X by L according to the Fourier's law of equation, heat conduction equation. Right? We can take from here. At the same time, for convection, the resistance, thermal resistance 1 by HA I said. Right? This is the 1 by HA. Right? At the same time, radiation heat transfer. The radiation heat transfer. See, I discussed this. 1 by this is the resistance, the thermal resistance of radiation heat transfer. Right? Don't worry. In the first case, in the first column, in every case, in the first column, description will be given. Second column, correlation will be given, or validity will be. Third column, notations is third. A notation same then clear is third. Q ante heat flow. Watts with units you will be given. K ante thermal conductivity. Area is nothing but area. Km. See here, Km is mean temperature, mean thermal conductivity, like that. See here, replace Km, Km by, right? TW, T infinity, H, everything, every notations will be given. Sigma and F. Prati conduction, convection, radiation, everything, for everything it will be given. Same description, correlation, and notations. Next step. After that, we discussed when I discussed hollow cylinder. Should a hollow cylinder with resistance? Ln R2 by R1 divided by 2π KL. That we discussed. Ln R2 by R1 by 2π KL. Anyway, this is the simplification of next case. Right? What is R1, R2 is given? What is the PIT1 is given? Some notations will change. Different notations, textbook, teaching notations will change. Don't bother about it. This is the resistance. Alage the spherical thing too, we have discussed the resistance. That is some 4π R1 R2, R2 minus R1 divided by 4π R1 R2 like that. That will also I show. This is the hints. See here. Immediately it is there. If it is a hollow sphere. R2 minus R1 divided by R1 R2. 4π K R1 R2 into R2 minus R1. That is like so if I simplify it, then what I do? R1 R2 minus R1 divided by 4π K R1 R2. That is the resistance, right? And the temperature profile. If the resistances are known, you can simply find out the temperatures based on it. Next step, composite slab. Composite slab we can discuss this. L1. This is L1 and LA LB L1 LB. With effect of convection. Convection and 1 by H, 1 by H. Data book, every equation is given, you must know how to use it. How to apply it. Next step. Composite cylinder. See, with the effect of convection is given directly. If you don't want convection, remove it. That's all. The resistance will be Ln 1 by 2π L, Ln R2 by R1 K1 plus Ln R3 by R2 K. Same thing we have discussed. The end equation. How to derive? We cannot do it in the data book. But the final end result we can cross check here. If the problem is given directly, we can use this equation, whatever is given or whatever is required. Based on that, we apply it. And this one, composite sphere. This composite sphere. Right? Next step, this one, another geometry. There is no question to say in the graduation level or whatever graduation is, this is out of syllabus. If the data book is given, use it. This is another type of geometry. For that, you need to use this equation. Strictly, if the problem is given on this, right, you can use it. You see the geometry inside this and outside this. I said see the equivalent diameter kind of thing, right? Like that. Anyway, though he won't give this kind of complicated issues at graduation level. And see, this is eccentricity. We have studied the eccentricity. Eccentrically, if it is moving, That means two centers. ఒక చిన్న బౌల్లో ఒక చిన్న గోళీ అలా తిప్పండి. తిప్పితే అది బౌల్ సెంటర్ వేరే ఉంటుంది, గోళీ సెంటర్ వేరే ఉంటుంది. The distance between the center of that particular sphere and the bowl, that is called as the eccentricity. ఇది బౌల్ అనుకోండి, పెద్ద సర్కిల్. ఇదేమో చిన్న గోళీ అలా తిరుగుతూ ఉంది, ఇలా ఇలా. Right? If the geometry is like that, you don't get this kind of questions. Don't worry. For understanding, I'm telling you. Next, see this one. This one we did one problem also. Right? So this is a BC, equivalent diameter here we have to, equivalent radius we have to find out here. Equivalent radius 2 we need to find out. How to calculate that equivalent radius? R is this one. So the equivalent radius we have to find out. This is R1 and this one is R2. Right? So 1 by R equal R2 and 1 by R2 is equal to 1 by RB plus 1 by RC. Then simplify this equation. R3 is equal to the equivalent 1, equivalent 2 and then R2, R3 and this 1 by R3 is equal to 1 by RD plus 1 by RE plus 1 by RE. Then simplify this equation. R4 is as usual. So total we can put it. Areas also can calculate. Area law calculates here. I explained in the problem. Right. So in this way, we can go for this heat source. I said heat source. Finally, PPT would channel. Right. So heat source admits with internal heat generation. If you consider, you'll get the equations like this. You will leave the second one. The first one is enough. Second one is for the radial things. Sorry, for idea. First one is the plate with internal heat generation. Second one is the cylindrical coordinates with internal heat generation. Right? It could be a cylindrical or spherical, whatever. These are the equations. If it is a hollow cylinder, it is like this. With internal heat generation. Don't worry, you don't get much questions or complicated questions on it. Simply substitute and questions only get, because all these will be covered in MTech, not in BTech. Right. Next, types of fins. These are students. Heat transferred by the fin. This is the temperature profile equation. Right. So if it is a long fin, the temperature profile equation is e power minus mx. We derived it. Heat transfer by the fin is this. We also derived this. But here root over hp by k. Root over hp by k and the total terms to the power 1 by 2. 1 by 2 is 0.5. Tb minus T infinity it by 2. Ultimate meaning is same. Right? For example, infinite long fin is this one is infinite long fin. Second, the short fin, end insulated. The same thing we have derived, the temperature profile equation, the temperature profile which I have shown in the top. Right? Again, heat transfer, the derived, we derived one. This one is also derived one. Right? This is the fin efficiency we calculated. Tan HML divided by ml. For this also we can calculate it 1 by ml, but I did not do here. Very simple one. Fin efficiency also. That means my intention is don't need to remember everything. You need to know the procedure. When the problem is given, you understand the problem. You try to identify the equation. Just note down the equation. Just copy this equation and do it. See, this is the short fin which end is not insulated. This is the equation I said to attain it, and this is the equation for the heat transfer. These three equations are essential in fins. Next, charts can also be used, but don't go to charts. Whatever I explained, that is enough for you. These are the numerical methods, two-dimensional nodal equations. But this is not in the syllabus. So you don't bother. These are the MTech level cases. See, for numerical cases also he has given here. That means this much complication is this. Without this data book, you cannot move with the. You should be aware of this data book, how to use it, where the formula is. Then you can do the heat transfer process. So my intention was why I could not show this data book at the beginning. If I tell you that there is a date, every formula is there in data book means you people won't concentrate on concepts. So that there is a big disadvantage that you cannot do the problem. Concepts as well as problem solving with the help of data book is needed. Right. Next, if you see this lumped analysis, this is the lumped analysis equation. Right. So this also given. Say instantaneous heat transfer, total heat transfer. Time constant. Time constant. He is asking you to calculate time constant. So like this. Everything is available. Here everything is given. See, LC, the significant length or characteristic length, V by surface area. Buyout number. HLC by KS. KS here is clearly indicated. HL by K we are using in the Nusselt number also. K fluid there. Here K solid. Right. So this is byte number. See Fourier number. Instantaneous heat transfer, total heat transfer. See thermal electricity, everything is here. You don't forget, about it. Forget about this equation, Taylor equation. Right. Next step, transient heat conduction or semi-infinite solids. Semi-infinite error function error function. This. Right. If you want to calculate the heat transfer in that case also, this is the equation we have to use. No need to remember anything. Any equation, not anything. Anything means Sadhudan and Japatla. If you want to derive something, fin derivation, you need to have the concepts. Without concepts, you cannot derive it. But any equation I'm telling, for any equation I'm talking. Next, these things. Leave it. Leave about this. Leave about this also. See, I said in the last class, Z value and ERF Z value. If you know the Z value, you can calculate the respective ERF value. If you know the respective ERF Z value, then you can calculate the Z value. Ulta, it is Ulta process. It is an Ulta process. Right? So next. We can do with the help of this also, but chart also. If you are familiar, you can use, because the easiest one is the tables. I can say, because you will get the direct values. If the table is provided, you can get the direct values. In the graph, see the scale is from 0.3 to 0.1. In between, if you put scale, you may not get the accurate value. That's the reason. If the table is available, use table. I say, right? This is about the semi-infinite solid. Next. Infinite solid. అంటే మనం ఫస్ట్ డిస్కస్ చేసేనే ఇన్ఫైనైట్ సాలిడ్, తర్వాత సెమీ ఇన్ఫైనైట్. అక్కడ ఆర్డర్ డోంట్ బాదర్ అబౌట్ ఆర్డర్. ఇన్ఫైనైట్ సాలిడ్స్ x by x t x by l t naught center line temperature, everything is given in right side, third power. Suppose if it is cylindrical, same thing. It is spherical, it is given. Infinite plate, temperature, time history. నిన్న చెప్పాను మీకు చూడండి, ఇక్కడ నిన్న నేను ఎక్స్ప్లెయిన్ చేసిన దాంట్లో 1 by Biot number is given, but here he has given the HL by K. You can calculate Biot number here, or because if you are going to use data book, so we have training class at 12. Can you please stop meeting before 5 minutes? Yeah, surely. I sure. Because now it is, I stop at 11:55. Is it okay? Is it okay? Yes, students.
Okay, sir.
Absolutely fine, sir.
Yeah. Before 5 minutes, I'll stop. Thank you. Sir. So, because you are not allowed to calculate, allowed for the textbook values. You are allowed only data book. So, అందుకే నేను చెప్పాను difference. After 1 by Biot number calculate చేసేటప్పుడు first you have to calculate with the help of Biot number only you can do it, because Anyway, you have to calculate in the problem Biot number. Without Biot number, you cannot check it. ఆ Biot number value ఏదైతే ఉందో అదే వాడాలి డైరెక్ట్ 1 by Biot number మళ్ళీ calculate చేయాల్సిన అవసరం లేదు. Right? You know Fourier number, simply Biot number will get it. But in case of cylinders, I said Biot, again you have to calculate HR by K, not Biot number there. Right? Be clear on this. So start doing some problems so that you will understand, you will get doubts. Right? Simply listening, you won't get much doubts. Right? So while solving problems, then only you will get doubts. Right? Infinite plate temperature at a particular distance x by L. The x by L is so. Right? X by L. Anyway, here also I shown 1 by Biot number, but here also you don't need to go for the calculation of 1 by Biot number. HL. 1 by Biot number is also correct. I'm not saying wrong, but those charts are not available. I'm saying that is the reason. Yesterday I could not find this data book, so I explained with the help of that source. Right. Next, you forget about the third chart, heat flow chart. You don't need to bother about it. Heat flow, leave it. Next, long cylinder. See here, it's R naught by K, same. Right? And here also alpha tau R naught square you need to calculate, not LC square. I specifically stressed in the class last class. These were designed for those particular values. For calculating Biot number, HLC by K, not HR naught by K. HLC with the HLC by K, you have to confirm for all three cases, right? But in the slabs plate case, we can directly use HLC by K. Cylinder and spherical case, you cannot use here the HLC by K, HR naught by K, alpha tau by R naught square. In place of LC, just we have to put the radius R here. These values we need to separately calculate it in addition to the HLC, because the HLC Biot number is nothing but to check whether the problem is lumped analysis or infinite. Semi-infinite solidity, you cannot get the equation. You cannot calculate the Biot number. The problem clearly identified, it will be identified. Long cylinder. At central line temperature, you use it. Let us say if it is at some distance, like R by R naught. R by R naught. Again, HR naught by K. Not HLC by K, HR naught by K. Right. Next for the sphere also same. For the spherical things also. Sphere temperature. Central line temperature, R by R naught. R by R naught is equal to 0 only, the first chart is used. Or X by XL is equal to 0 only, the first chart is used. The respective second charts will be used for at a distance R by R naught. If it is 0.1, it is greater than 0 to 1, it can be used. There are no tables are available, so better use these ones. Right? So semi-infinite blades. This is for the simply understanding. You can see this. So don't bother about it all. Periodic heat flow is not there in our syllabus. Even in MTech also it is not there. So these are for the PhD courses. So keep in mind, dear students, data book is bipartite. This data book designed for undergraduation, post-graduation, and PhDs. All will use this data book only. Even in some industries, for designing heat transfer issues, they use the same data book. This is international approved good data book. Okay, data book అన్ని మనం వాడాలంటారు. నేను ఏమైతే specifically whatever I stressed, I focused use those only useful at undergraduation level. Next, so this is about the conduction. Radiation లో మళ్ళీ radiation explain చేస్తాను. Convection లో convection explain చేస్తాను. After this, we have to go for the convection problem, boundary layer and all. We have to do. That will be covered in the next session. After that, doing the problem is very important. Convection problems chala easy. A steps and different steps for it. You can do it. First, you have to identify the fluid. You have to identify the geometry. You have to identify the external flow or internal flow. Properties తీసుకోవాలి. Right? Reynolds number calculate చేయాలి. Laminar flow or turbulent flow చూడాలి. If it is laminar flow, what are the equations? Turbulent flow, what are the equations? అవి కూడా మీరు ఏం గుర్తుపెట్టుకోవాలి. For example, I'll show you. All these are the equations. It is very, very, very tough to remember, right? So we start with here. External flow, plot here. These equation, all equations will be used. It is a laminar flow. It is a turbulent flow. If it is turbulent flow, we have to use some other equations. If it is in the laminar turbulent region, we have to use some other equations. The thing is starting somewhere. I discuss the conditions. What are the conditions? Right. So sir, all non-dimensional numbers are given. It is 1111 page number. Once go through it. The symbol is given. The groups are given. Name is given. Significance is given. Each and every significance is given. Right. Okay. Fourier number, Grashof number, Nusselt number, Peclet number, Prandtl number, Rayleigh's number, the product of Grashof and Prandtl number. Right? Many numbers. Reynolds number, Schmidt number, Standard number. I have shown some numbers. Right? So I guess the time is over now. If you have any doubts, you can raise your questions. I'll discuss. And then the next class, let us see with the boundary layer and the energy, thermal, what is called hydrodynamic boundary layer and the thermal. Right? So once if you in your free time, go through this data book quickly. Just you observe it and go through your PPTs or notes and try to apply it. Those who are ambiguities. If you have any doubts, let me know now or afterwards. It doesn't matter. If you don't have any questions, let me know so that I can quickly stop it, because you said you have training. Any questions?
No, sir.
Yeah. Can I end the meeting? If you have questions also, don't worry. You write the questions and you can ask me at any time. I'm allowing you to ask the questions.
Okay, sir. Thank you, sir.
Yeah, right. I will end the meeting.
Thank you, sir.